Hi YouTube. Today let's solve the LeetCode problem, find all anagrams in a string. So let's first take a look at the problem here. So this is a part of the LeetCode May challenge, and this is a medium difficulty problem. So given a string S and a non-empty string P, we want to find all the start indices of P's anagrams in S. So we know that strings consist of only lower English letters, and the length for both string S and P would be no larger than some threshold. Also, the order of output does not matter in this case. Okay, so let's first understand what an anagram is. So an anagram is when two words, they have the same number of letters, but they can be arranged differently. For example, in this case, for ABC, the anagrams could be ABC, or BAC, or CAB. So any arrangements of these letters. So before we dive into this question, let's first think about its subproblem. So one subproblem here is, let's call it is anagram. Let's say this is a function that could take in two strings, S1 and S2. And this function will return true or false as output. So what this does is it just takes in two strings and checks whether they are anagrams or not. And let's do one example here. We have AA, BC, which is string 1, and we have BCAA, that is string 2. Obviously, there are anagrams. So how does the algorithm work? So what we can do here is we can convert these strings to a map of characters, and for each character we would have the count of the character as value. So let me just demonstrate here. So we can convert string AABC to a map of A. We have 2. We have B is 1, and C is 1. And for the second string, we also have A is 2, B is 1, and C is 1. In this case, because both of the maps have the same of characters and the number of the value for each character is the same, so we know that these two strings, they are anagrams. Okay, so now we have the isAnagram function defined. How does it help us solve the main problem here? Let's look at this example from the previous slide. We have string S and we have string P, and we want to find all the anagrams of P in string S. One naive approach that we can take using the isAnagram function is we can check all the substrings in S that has length of P and compare that with P and see if it's an anagram. If it is, we just push the index to a result array, right? For example, what we can do here is we can check first, because length of P is 3, we can check CBA, BAE, AB, and all the way to the right. The last we would check is ACD, then it reaches the end of S. So this approach works, but the reason that I said this is a naive approach is because the runtime is not optimal. Let's say we have string S of length n and string P of length k. Because we're checking n times, and for each time we're comparing k characters, so the runtime would be n times k. And because in some cases k can be equal to n, so this is essentially O(n) squared. So how can we make this algorithm more efficient? In fact, we can actually make some minor tweaks to the algorithm such that we make the n a constant, and the overall runtime would be on. And we're going to solve this with the sliding window technique. So the way it works is, let's first initialize a map. Let's put P into a map. We've done this before. We have A is 1, B is 1, and C is 1. What we want to do is we want to loop through the string S, and whenever we find a character, let's say C, we're going to decrement it in the map. So this becomes 0. And once this becomes 0, we just remove it from the map. And we check if P is an empty map, then we know there is a anagram. One thing to note here is that the window length is equal to the length of P. So in this case, it's 3. And as we are sliding the window, let's say the first window is CBA, the second is BAE, we need to remove the new character. In this case, we need to deduct this character from the P, but we also need to add C back. And I'll quickly demonstrate how this works by going through this array and P. So initially we have A1, B1, and C1. This is reflecting P because it has one of each character, A, B, and C. And let's start with the first window, C, B, and A. In this case, we see that whenever there's a new character, we deduct it from the map. So it becomes 0, 0, and 0. And when we have a 0, we just delete it from the map. That's why we get an empty map after matching C, B, and A, the first window. And let's say we have a list to keep track of all the indices that we want to return. In this case, we just push the start index, 0, to the list. And now let's move on to the next window, BA and E. In this case, we have a new character E. We have to deduct it from the map. And because there's no E in the map already, it's an empty map, we just use the value -1 as a placeholder. It's valid to have a negative value in the map. And also because we move away from C, so we add C1 to the map. Now if we move the window again, what we get is A and B. In this case, B is a new character. We have to deduct it. But we also have B. We also move away from a B, so we need to add 1. That just cancels out, so we have the same result map. And similarly, for the next window, we have A and A, so it's the same result. And now let's move on to the next window. We have BAB. We get a new B, we have to deduct it. And we move away from an E, so we +1. So this -1 becomes 0. And because it's a 0, we just remove it. And this is what we get. Now, the next window is A, B, and A. We have to deduct A, and we also have to add 1 to B. So this becomes 0, and we just remove it. So for the next window, we get a new C. We move away from A. In that case, we just deduct C to be 0, and we add A, which is also 0, and this just becomes a empty map. And in this case, we push the starting index of the window to the result map, which is 6 for B. So we have 6, and the final window we have here, we deduct 1 for D, and we plus 1 for B. There we have it. This is the result we have for the input S and P in this question. Now let's take a look at the Python implementation of this function. First, we initialize the map object for characters in P, as well as a result array, which will hold all the indices. And at the end of the function, we'll return this result array. Next, we want to populate the map for P. This map contains the count for each character. So for each character in P, if it doesn't exist, we initialize it to be 1. Otherwise, we just increment it by 1. Now let's take a look at our main loop. We loop through characters in string S one by one. In this case, I is the position of the rightmost character in the window. Remember the algorithm. For every new character, we want to decrement it by 1. In this case, we define a small helper function to do it, which we'll get to in a second. Next, we want to increment the character when the window moves away from it. In our case, the position of that character is I minus length of P, which is equal to the window length. Note that we have an if condition here. This is because we need to fill the initial window first, and only start sliding when the rightmost position is greater than the window length. We then increment the character by 1 with the helper function. At each position in the string, we want to check if the map is empty or not. If it is, we push the starting index of the window to the result array. Now the final piece of the code. Let's see the helper function. The helper function takes in a character and a numerical value x. For the purpose of this question, x will only be 1 or negative 1. 1 for increment and negative 1 for decrement. If the character is not in the dictionary, we initialize it to be 1 or negative 1. Else we increment or decrement the value based on x. If the count is equal to 0, we simply remove it from the dictionary.